Welcome to lesson 1.4. This one's definitely going to be shorter, but it might be a little harder to grasp. Absolute values make us do some different stuff when we're solving equations. But just to quickly define absolute value for you guys, it's the magnitude of a number. Magnitude is like its plain value. And so the magnitude means that the sign doesn't matter. So the magnitude of a number, regardless of its sign. So the example I always like to give is like a car driving. If I'm driving north towards Green Bay, that's 60 miles per hour. I'm driving 60 miles per hour. Now, if I decide to drive south towards like Chicago, also at 60 miles per hour, on a graph, we might call this a positive direction and this a negative direction. But the purpose of absolute value is saying that the positive and the negative don't matter. I'm driving just as fast as you are. Just because it's in a different direction doesn't mean you're faster than me. So that's one situation where absolute value is actually the appropriate thing to do. We don't care that I'm driving south. I'm still driving 60 miles per hour. Speed is one example of an absolute value thing. Now, velocity kind of sounds like speed, but the purpose of velocity is that it does care about the direction. So there's certain times we do, and there's certain times we don't. So just plain speed, we definitely don't care, because 60 miles per hour is 60 miles per hour. So along with absolute values comes a couple of nice little properties, good things to remember. This first one, absolute value of A is greater than or equal to 0. A stands for any number. Any number we put in here is greater than or equal to 0. Maybe a simpler way to think of that is absolute values cannot be negative. When we choose to use absolute values in a problem, it's because we're saying we don't care about the direction, like my little driving example. It's the purpose of an absolute value, so we do not let absolute values come out to negative numbers. A can be negative, but once I take the absolute value of it, it shouldn't be. So my 60 miles per hour south could be negative 60, but then when I decide I'm talking about speed, I get rid of that negative because we realize it doesn't make sense for our problem. That's the purpose of an absolute value. So another way of showing that, technically a different property, but it follows similar logic, is that the absolute value of a negative and positive of the same number, so like the absolute value of negative 3 and the absolute value of positive 3, are really the same thing, because all I'm looking at is the sheer value of that number. They're both 3s. This one's just got a negative, so it'd be down on a graph instead of up or something like that. So if I were to use algebra, what these bars do is once I have everything inside simplified, so this is just a number, it gets rid of the negative if there is one. So this becomes a positive 3, this stays a positive 3, and they match. So absolute value's purpose is saying I just want the sheer value of the number. All right, so when we're solving absolute value equations, we're going to follow two very strict steps. This first one, the reason we have to isolate the absolute value is we cannot use the distributive property. Very important we don't try to do that. Absolute values are a special kind of parentheses that has their own rules and does their own thing in math. Using the distributive property would disturb that. So we would not come out with a correct answer. All right. And then step 2 is once that absolute value is alone, once we've done our algebra steps to get that alone, there's going to be two possible solutions. Okay, because inside those absolute values, remember, this is the property we just looked at. If I put a negative number in the absolute value and a positive number in there, they come out to the same thing. What that means for solving an equation is this works and this works. Two solutions. Almost always two solutions. There is a situation where you'll only get one solution, and that's if the number inside is 0. because what's the difference between a negative 0 and a positive 0? Not a dang thing. So the only time where we'd have exactly one solution is if that's a 0 in there. Otherwise, we got to split it into 2. So let's take a look at what that looks like. Starting real simple, this absolute value is already isolated. So this is the conceptual part. This is the abstract part that people struggle with if they're going to struggle with this lesson. 6 is what we want the absolute value to equal. What are the two possibilities? What are the two things I can put in an absolute value that come out to 6? The obvious one is just 6. Negative 6 is the less obvious one. But because of that, I can have this absolute value equal either of those, and it'll still work. Those are going to be my two solutions. So let's erase that quick. And what I like to do here is I draw myself a little squiggle, so I know these are two new equations. All right, and I've got my x minus 4 equals 6, and my x minus 4 equals negative 6. All right, realize that I left the absolute value symbols out. This is our way of getting rid of those. Okay, with parentheses, once the parentheses are alone, we can just ignore them. Or we can use the distributive property, not for absolute values. Absolute values, we have to get to this point where we split into two equations. Now the steps for these are usually the same once we're at this point. For both of these equations, the only algebra step I need to do is add 4. So even though it looks like twice the work, it's really not. You're just kind of copying your same steps over. So these should be my two solutions. And just so you know I'm not lying to you, let's plug these back in. What's 10 minus 4? Well, that's 6. So I get absolute value of 6 equals 6. That works. Now let's plug in negative 2. Negative 2 minus 4. Negative 2 minus 4 is negative 6. Well, what's the absolute value of negative 6? Those bars make it a positive number. All right, so it checks out. We're good. I checked my work for you guys. Please, please, please rewatch this little explanation where I describe why we get two solutions if it didn't make sense to you. All right, that's the big thing that people usually trip up on in this lesson. All right, let's take a look at the next example. I'll keep this one right over here. Won't need too much space. So I've got a little bit bigger problem. One more like the harder ones we were doing in the last class. But still manageable. You guys got this. So now we do have to follow that first step, isolate the absolute value. So right now I'm going to treat this whole absolute value like it's one untouchable thing. I've got to get everything else away from it. So there's a 10 being subtracted. Opposite of subtracting is adding. So I'm just going to do that. So I've still got my absolute value over here. Negative 4 plus 10 is 6. Now my absolute value is alone. Now I do what I did over here. It's just a coincidence. They both are supposed to come out to 6. But I split into two equations. So I have 3x plus 9 equals 6. And I have 3x plus 9 equals negative 6 for the same reason as over here. To get 6 out of this absolute value, I'm okay with this absolute value coming out to a negative or a positive 6 when I plug my x in. So minus 9, over here I'll do the same. Handle our addition and subtraction steps first. Always a great strategy. Both of them have to divide by 3 now. See, the steps like to match when you're doing these absolute value problems. It's really not like you're doing two whole equations. All right, so these are my two answers. I'm just going to talk them through. I'm not going to write the whole thing out. But if I plug in negative 1, 3 times negative 1 is negative 3. Negative 3 plus 9 is positive 6. Absolute value of positive 6 is positive 6. And then 6 minus 10 is negative 4. That's good. Negative 5 for x, 3 times negative 5 is negative 15. Negative 15 plus 9 will be negative 6, but that absolute value bar turns the negative 6 back positive, gets rid of that negative sign for us. So then we're right back to 6 minus 10 equals negative 4. So if we plug these back in, they both still work. Again, please rewatch this part of the video if you didn't understand why I split into two equations. Hopefully it makes sense, otherwise ask in class and I'll try and give you another way to understand it. For the modeling problems, we're actually going to go through this more in class, but I just want to give you a little idea what it looks like. So when we're actually solving a word problem for this, what we want to do is goal, so our target number, minus error, minus actual value. So like x, the number we would plug in, equals the error. Okay, so what that means is this is like the average or the middle. This is what we actually get. That's our number. And the error is how far off we're allowed to be. Now, when we actually do some examples together, that's going to make a lot more sense, but this is, for absolute value problems, really the crutch we will rely on for word problems. So we'll practice that a bit in class, but for this video, I don't know if it's worth going into when I'm not there to answer questions. They get kind of weird. Now, before anyone gets intimidated because there's absolute values on both sides, you just choose which side you want to split up, all right? So it's really not that bad. The idea here is the sides have to be equal or opposite of each other. And so to make that happen, all we have to do is choose one of these sides to be the positive or negative one. So I like to choose the simpler side to be the one that changes. So 3x minus 4 is what I'm going to keep the same. And x is what I'm going to make a positive or a negative. So don't be intimidated. It's the same exact type of problem. You just see absolute values on both sides. You actually get to choose which side you make positive or negative when you split it up. Okay, so this is a little more abstract. It's harder for me to make this concrete for you because there's variables on both sides and there's absolute values on both sides. There really aren't many applications for absolute values on both sides that are common in the world. So it is something in math that we can do and solve, but you're not going to run into word problems that make you do this. All right, so if we're solving, I would subtract 3x on both sides to get the x's together. Remember our strategies from 1.3. So I'm left with a negative 4 over here, and x minus 3x is negative 2x. Left with a negative 4 over here as well. Negative x minus 3x is negative 4x. So this one has to divide by negative 2. This one has to divide by negative 4. When you have absolute values on both sides, the steps aren't always going to match anymore. They will for a while, but eventually something's going to be different. So I get 2 equals x, and I get 1 equals x. All right, now let's take a look and see if that made sense. So if I plug 2 in, 3 times 2 is 6. 6 minus 4 is 2. The absolute value makes it a 2. And if I plug 2 in for x over here, I hope that's obvious. Absolute value of 2 is 2. That one checked out. Let's check our other number. Plug 1 in. 3 times 1 is 3. Minus 4 is negative 1. But that negative 1 is in an absolute value. Turns that negative 1 into a positive 1. Please notice, guys, that I never actually use the absolute value to make things positive until I'm done simplifying everything. If you do it too early, it's actually an incorrect step. So that second number works as well. Good for us. All right, let's do one more of those, a little bit harder one, and then we'll do the ones with the weird solution. So a little more complicated of a problem here. Now, let's make a quick decision. we still have to follow our absolute value solving steps. The first step was isolating an absolute value. One of them already is, one of them is not. Okay, so in this situation, if I don't want to do any algebra steps first, what I have to say is the one that's not already isolated is the one that has to get the positive and negative sign. So I'm going to leave the 4x minus 10 alone for this problem. On the other side, I'm going to turn the absolute value into a parentheses now. Remember when I called it a special pair of parentheses? That's because for math purposes, it acts like a pair of parentheses, just we can't distribute into it. But now that we're doing our step to break up the absolute values, we can. So now I'm going to put a negative 2, 3x plus 1. So this side's the positive side, this side's the negative side. This is a weird problem, I get that. If you're following along, great. If you're not, understand, I kind of expect a lot of you to struggle with this big of a problem. There's a lot going on here. But now we're back to just solving steps. So hopefully what I do from here on out makes sense. I'll work on one equation at a time because these ones are a little bigger. I distributed 2. Now I've got to get my variables together. If you remember, I prefer to keep my variables positive, so I'm going to subtract the 4x instead of subtracting the 6x over there. Otherwise, I'd have a negative with the x, and I just, when I have the choice, don't like to do that. Now I'll subtract 2 to get the constants all on the same side. And last thing to do is divide. So I get negative 6. Let's take a look over here. Distribute negative 2. I get negative 6x minus 2. Then I'm going to combine the x's. Now I want to add 6x. Same reason as before, I like to keep my variable part positive. Add 10 to the other side to get all the constants together. And then divide. Well, that's not pretty, I'm going to get a decimal. And you know what, if the decimal concerns you, let's try it out. All right, if it doesn't work, I'll go back and check my algebra steps. Worst case scenario, I made a mistake somewhere. But let's give it a try. Decimals aren't always a bad thing. So 0.8. 4 times 0.8 is 3.2. 3.2 minus 10 is negative 6.8. All right, the absolute value is going to turn that into a positive. 3 times 0.8 is 2.4. 2.4 plus 1 is 3.4. The absolute value is going to keep it positive. And then 2 times 3.4 is, guess what, 6.8. So please don't be intimidated by the decimal answers. If you don't like it, just give it a try, actually plug it back in. But it worked out. The negative 6 as well. 4 times negative 6, negative 24. Minus 10 is negative 34. The absolute value makes it a positive 34. 3 times negative 6 is negative 18. Plus 1 is negative 17. The absolute value makes it a positive 17. 2 times 17 is 34. So both our answers check out when we plug them back in. That's good news. There's no way we were wrong. All right, really hard problem. Really expect questions on this one. So please come to class with some. Now, I'm not actually going to go through an example for this one. We'll do plenty in class. But extraneous solutions happen when we go through all our algebra steps and one of the answers just doesn't work. Now, I want to show you when that happens because it's actually a very specific situation. If I have a variable in an absolute value, and on the other side, I have a variable not in an absolute value, I will get an extraneous solution. There's something weird with how the negatives work with our way of solving absolute value problems. In this situation, there's only going to be one solution. All right? So we'll take a look at that in class, but just understand this is what extraneous solutions means. We find two answers. One of them doesn't actually work. All right, so I know it sounds weird, but when you see this, and this is part of recognizing patterns in math, I could just tell you to check your extraneous solutions in every problem, but trying to be nice. If you can figure out that pattern and realize what I'm trying to get you to realize, you'll only have to check for certain types of absolute value problems. All right. Hope you have some questions for me. I'm sure there's going to be some. This lesson is never just as straightforward as the first couple. So thanks, guys.